My name's Steve. I work in automation or automationeering with Bob and Ology and a few others here. What? And I'm going to talk about service meshes and a few Docker patterns and basically some networking stuff with Docker. And our team, we started off as a chef team, so we look after, this is our chef estate. So the green ones are nodes, the blue ones are applications. And if we find one here somewhere, if this thing updates, we can see, and the red ones are environments that host those applications. So we also recently started looking after a bunch of other services, but that's kind of our main function. Anyway, so before we talk about all this Docker and service mesh stuff, we need to talk about microservices. I think, or I hope everyone's heard of them and knows what we mean when we say it, but I just want to clarify because I want a shared understanding of what we mean when we say microservices. So when I say microservices, this is basically what I mean. I've got a monolithic service, looks like this. This is what our microservices look like. Okay. But jokes aside, what we're trying to do with the microservices, in my opinion, is we're trying to make it really easy to maintain and test and deploy with high confidence. So in order to do that, we want them to be small. It's much easier to test 100 lines of code than 100,000 lines of code. It's much easier to make sure that there's no duplication. And we want to keep them really simple. So we don't want to add extra complexity into our applications because that's going to make it harder to maintain them. So with the service meshes, you're basically taking a lot of the complexity of that network out of your application, and your application can just do what it's designed to do, your service. So we started using gRPC a while ago, which depends on HTTP2. And we've always been using HA proxy and Nginx and stuff as our load balancers, which work really well with HTTP 1.1. Basically, the difference is in HTTP 1, every request you make is its own connection. So you'll create a connection, send some headers, get some metadata, send the request, it'll get processed, it'll get returned to you, and cool, that connection's done, which makes it really easy to load balance. HTTP 2 uses a persistent connection. So it'll send all that metadata and create the connection at the beginning, and then all subsequent requests will use that same connection, get processed, come back. So you're not establishing new connections the whole time. So if you look at Nginx's sites, when they say HTTP load balancing, you'll see this picture. And what we have here is we've got HTTP 2 coming into your Nginx. And then to all your backend services and clusters, it's load balancing with HTTP 1, which is kind of great because at least you're not establishing a bunch of connections on the client side, but you're still wasting a lot of time and stuff here. And if your backend services are written in gRPC or something that depends on HTTP2, you're not going to get load balancing. What you're going to get is more like this. You're going to hit your first request for one of the services. It's going to find one of your backends, create a connection, and anything else, whether it's the original client or any other client connecting in, it's still going to go to the same backend service, and you're just going to ignore these. And that was our problem. And we dedicated quite a lot of time to trying to fix this with HA proxy and Nginx. And basically, the problem comes down to that this logic, you could theoretically establish a bunch of connections to your different services and then just choose one each time, but that logic has to be available in the client that's connecting. So Nginx has to have that built in. It has to know how to talk to those services, which it doesn't at the moment. I expect it will soon, but right now it doesn't. No. That's not one of my slides. Do you think QuickTime died? I just wonder if QuickTime's still doing stuff. Don't look at that.
Miracles happen.
I think it's working, right? I don't know. Who's good with technology? Okay, so next slide. So the next option you have is you actually build all your load balancing into your client. This is one of the recommendations on gRPC. So what you do is you write your client-side application, you talk to a bunch of servers, and then in your client, you've got to find out where those servers are, what's available, establish connections, decide which connection to use for which request or what load balancing algorithm. You've got to handle your fault tolerance in the connections and reconnects. you have to do some kind of service discovery. If you scale out more servers, you have to reconfigure those clients. Basically, not keeping our application simple. That is making our application very, very complicated and difficult to maintain. So that's not great. So we obviously had these gRPC services, so we started looking at other options. One of the ones I came across was Linkerd. Linkerd is awesome, and I think it's the most widely used service mesh at the moment. And when we started using it, this was the only topology available. There are more options now. But basically what you do is you run a Linkerd instance on each host that is serving traffic. So these are your Docker containers or whatever applications, and these are your Linkerd services on that host, on each host. So when your client service here wants to talk to world, instead of finding all the worlds in the environment, it talks to its host Linkerd instance. That host Linkerd instance knows, okay, well, world is running on host 1 and host 2 and host 7 and whatever it may be. And it picks one of them, does the load balancing in its service mesh, and then it goes to the Linkerd instance running on one of those hosts and routes back to your application. So that's how all of the HTTP2 load balancing that I've seen generally works. You connect to something that's got a bunch of them running in your environment with their own connections, and then it'll manage that for you and connect out to the other application. And this works, I want to say really well, but that's not accurate. It worked for a long time. But we ran into some issues, the first of which, you can't really see those. It's really complicated. And I'm not smart enough to do this effectively. And basically what you have here is their sort of system for defining those routes and service discovery. On the other side, you've got namers, where you can configure rules and write this complicated stuff on how to look up things and match things. And then you've got your routes. And then my worst part is this dtab section, where you can have maybe 10 of these lines. Most of the time, I don't know what they do, and I'm just trying to figure it out. And the problem with this, the biggest problem, was that I could never remember this. Whenever I came back, I had to figure it out all over again, because it was really complex and different to everything else. It's their own thing. Yeah, so then the other big problem with this, or that we have, is we're obviously a big chef shop. So our kind of common pattern for managing configuration is to run chef, and it builds a template file with all of your configuration in it. The way Linkerd wants to work is configuration via API. So it'll have your initial config, and then any changes will be calls to the API to update that routing. So that didn't really match us. But there are some patterns you can use to solve that. So I'm going to segue a bit and talk about some Docker container patterns. So the first pattern is the Sidecar pattern. It's very common, especially in service meshes. And this is something you could use to solve that configuration problem. So here we've got our Linkerd configuration API, which if you want to update config or routes, you'd talk to. And what you do is you have your one container running in its network namespace, and then you add another container, and you give it the same network namespace. So if you localhost here or localhost here, it's the same network, right? And then what you do is you mount your configuration template into this watcher, and here you have an application that's just watching that config file for changes, and when that config file changes, it talks to localhost to your config API and updates it. So you can change it to use the config file and still update via the API. Or you can do it the other way. If you've got an application that depends on a config file update and you want to make it API-driven, you could easily do something that exposes an API, updates a config file, which your application loads. The other thing, which I'm going to demo quickly with the Sidecar pattern, is really handy, is let's say you're running your Docker images in don't look at that, in an untrusted environment. Can you see this? No.
Can you change to white background?
Oh, that's going to take me a while.
Just preferences and double-click the white one.
So I'm glad somebody's watching.
Double-click basic and it'll open up a white terminal.
You're basic. Okay, so I've prepared this little demo, and And basically what we have here is we've got a very simple Flask Python application called hello, which basically just has a hello world index, and I added an environment variable. So, and then I've got this command, which will launch a Docker container running it. I think I've already got something running on 5,000, so let's just go 3,000. And since our application is exposing port 5,000, I'm just going to map 3,000 on my local host to 5,000 and run this. And you can see I'm just mounting this hello file in, and we should be good to go. Now what? Oh my gosh. Actually, this is going to be easier than that. Where's my white one? So this doesn't have my screen session in. So let's do that again. No. Sorry. Just having some difficulty with this. So 3,000, let's map that to 5,000. And now we have got our application running 5. Does anyone run Notary? No. OK, so we run, or I run Notary, which expects all images to be signed, Docker Content Trust. And I haven't pushed this image anywhere, so there's no signing metadata, so that's what's mad about Notary. It's one of the other CNCF projects, and tough. Anyway, so now we can see our container is exposing 127.0.1, 5,000, which I've mapped to 3,000 on my machine. So if I call this, I'll get nothing, because this is running on localhost in the container, which is not the same namespace as my machine. So if we kill that, what I can do is, not that. So if we then, so I added that handy environment variable where I can tell it to listen on all interfaces. And now, hello world. Cool. But now the problem is we've exposed HTTP in an untrusted environment, which we don't want to do. We want to use certs. So without changing our container at all, we're going to switch this back to only do localhost. I'm going to switch to a secure port. So I'm bind, because I'm not running a sudo, so we'll bind 4443 on my machine to 443 on the host machine. Thank you. Glad someone's watching. That was a test. Well done. Cool. So now we're still localhost 5,000. I've mapped these ports, and I've set the name of this container to hello. Oh, cool. It's still here. Just going to have to turn this off because it's on for me by default. So now I've got this other handy Nginx container, and I've got a default, which is basically just taking 443, adding SSL, and sending it to 5,000 on localhost. And what I can do is hopefully run this Nginx container. I just wanted to, I thought I might have to change something. No, I don't. So I'm mounting some certs in there. You can see here, I'm mounting some certs, adding the config to the Nginx config. And this is the important part. I'm setting the network for this one to be the same as a container named hello. So this is going to start up and be added to that same network that our other containers on. No. OK. One of these is open. OK, one. So now if I call this on 4443, which was the port I mapped locally, and it's a self-signed cert, so whatever. And now we've got secure communication and an untrusted network, and I haven't had to do anything to my application to make it hard, make it more complicated. So this is a very common pattern and very useful for service meshes. They use that kind of stuff a lot, and we'll see that later. Next pattern, I'm not going to talk too much about it, is an adapter pattern. The service meshes also use this quite a bit. It's if you want to send standardized data from machines or from legacy applications or modern applications that don't export data in the same way. Basically, you use a similar thing. You have another container in the same namespace that can intercept that traffic, parse it, standardize the format, and send it on. So things that are exposing a lot of different kinds of data. You can normalize that data before sending it to whatever server you want to process that. So you can also do that with service mesh. And then the last one, this one should be obvious why it's super handy to us from before. Excuse this, I'm not a designer. But basically now what we do is the same thing. We have our two containers, the one running our application. And now instead of doing all our routing in our application clients, we have a different client that does the service discovery, connection management, load balancing, and all of that kind of stuff. And all we do is, because we're on the same network, we intercept any traffic going from this one and then load balance it appropriately. And that's pretty much what all of the modern ones do. So the one we're running at the moment after shutting down Linkerd is Istio, which has not been without issues as well. But at the moment, it's running really well for us. We're super happy. It's a bit complicated. It basically relies on a third-party proxy service, in this case Envoy, which is the default. But you could run these as Linkerd, or Nginx as one called Engine Mesh, which doesn't yet support HTTP2, but I'm sure it'll be coming soon. But basically, Istio is divided into two sections. There's a control plane and a data plane. What we've been talking about so far is the data plane. I'm going to talk about that a bit more. So here we have our pattern where we've got our applications running, and then they're in a shared namespace, and you've got an Envoy proxy running there. And these are running IP tables, intercepting any traffic, and then deciding what to do with it. One of the awesome things is it's got HTTP load balancing, and we can run it with TLS. So this is actually MTLS that we run. So any traffic going out, so we don't have to make our application complicated. We can have a really simple using HTTP application, and our Envoy proxy is going to intercept all that traffic. It's going to do mutual TLS between services. So any traffic on the network is always encrypted. We don't have to do anything. And it's proper MTLS. It's not some shared cert that's the same everywhere. And those certs are automatically rotated every, I think it's 15 minutes or something crazy. So it's really secure. And it does our HTTP load balancing for us. And then we could have done this with Linkerd as well, or something else. But what's really cool about Istio is this section here. So what this does, Istio Manager is actually Istio Pilot. What that does is that's monitoring your service discovery stuff, and any changes that happen there, it's going to know about those routes, where to find those applications, and push those changes down to the various proxies in your environment so that everything gets updated and knows how to route to your different applications. And that'll happen real time. As you make changes, your environment routes get updated. Other section is Mixer, which we'll talk about a bit more, but that's all your telemetry. So all of your stats and information about the traffic that's going through your network is going to Mixer. There are also policy checks, which we're not using, or we use some, but not all of them. And then the last one is Istio Auth, and that's got your Istio CA, your certificate authority, and that's what's doing the certificate rotation along all of the Envoy proxies. So that's telling them to update. When you create a new node, it's checking in and getting registered and getting a new cert. Yeah, and that's pretty much it. This is, like I say, working really well for us. I can show you some of the telemetry stuff. There is one more component which we run, because we run in Kubernetes. You don't necessarily have to be running Kubernetes to run this stuff. And in fact, you can extend your Istio service mesh, or any service mesh, outside of your cluster to other applications, as long as you just run your Envoy proxy or whatever proxy and register it, and as long as it's got networking to your pod network, then you're good to go. We don't do that because nothing has networking to our pod network. And then there's ingress, which we use for traffic that's coming into the service mesh that's not part of the service mesh. So applications that need to talk to our applications in the mesh would go through an ingress, which will find out which service needs to go and then encrypts it for the network. So some of that stuff that we get, I can show you. So this is a simple bookstore app. This was basically Istio's example, which we're just running. And what we have is we've got a bunch of services were interested in the reviews. There's 3 versions of this reviews. So you see if I refresh the page a few times, sometimes there's stars, sometimes there's not. Version 1 has no stars, version 2 has stars, version 3 has red stars. So at the moment, what we've done is we've routed 50% of traffic to version 1 and 50% of traffic to version 2. Now, let's say we want to test some awesome new feature. We want to only make it available to a small part of our users, or maybe you only want to make it internal to your company or something. You would release a version 3. So if I go cd repos Legion, I think it's in here. So these are the YAMLs for that. So here's this default route I'm talking about. And here we can see this should be familiar to anyone who's used Kubernetes a bit. Obviously, it's kind of different, but this structure is very familiar. It's a lot easier to understand than the Linkerd stuff. I think most people here would be able to, without even knowing what this is, figure out what's going on. Basically, we're saying anything that goes to the reviews destination, put 50% of traffic to version 1 and 50% to version 2. Pretty straightforward. Sorry, it's black again. And then what we've got is another canary route, which is our awesome new feature. It's going to reviews. We've set it a higher precedence, so it'll get evaluated first. And we're saying any requests that have the canary header with yellow, send it to version 3. So then what we can do is we can turn on our canary yellow header and refresh, and now we get version 3 of the application. So you can do that not just on headers. There's a lot of different rules you can use for that kind of canary release stuff. And then in the routes, you can also add things like handling 503s. You can retry, or you can inject faults, and you can, if one service stops becoming available, you can eject it from the load balancing pool and do all kinds of fancy, awesome stuff. And then what's really nice is because any traffic that's going through your mesh, Istio knows about. So any request that's made from anything to anywhere else, Istio knows about. So it makes it very easy to add things like open tracing Zipkin, or what we've got here is Jaeger. This is basically on top of Zipkin, and this comes from, I think Uber made this. So I did this request earlier because I don't want to share my data, but basically this is Slot Machine. It's a token-based service, which we wrap LDAP with to add private key support instead of just username. But I can see I made a request for a new token. I can see it hit Istio ingress. I can see the whole request took 139 milliseconds. I can see how long it took in each one. I can see what the headers were and what the protocol was, and makes it very easy to debug. And what else I can see here is on the bank LDAP side, which is also HTTP2, I can see that my load balancing is working because this is hitting IP whatever with 6, and this is hitting IP whatever with 236. And it's very easy to know exactly what's going on in your environments, where the bottlenecks are, what errors you're getting, how often things are being hit. Yeah. And then there is the last thing. So if I just do grafana.adc, so you get all these handy dashboards, and you can see pretty much what's going on. And on a service level, you can see all the different services. It just takes a while to smash all the data on my phone, which I'm going to kill, but you get the idea. Anyway, yeah, I think that was everything. I already did that. Yeah, so are there any questions? Or yo.
So you mentioned that sort of stickiness problem with Nginx, the web.
Yes.
The sockets, has that gone away now?
I haven't looked. We started running Linkerd over a year ago. I imagine that it's...
with Linkerd, like how is Linkerd doing?
Oh, Linkerd, the routing always worked. That was never the problem. The problem was just too hard for me.
Right.
Yeah, so you've got to like find the custom routing rules and stuff in Linkerd, and it's like their own special
That syntax is complicated.
So I just want to understand, so that the client's connecting to Linkerd, like in that hello world thing.
Oh, that wasn't my hello world. That wasn't using Linkerd at all. That's just two different containers sharing a namespace.
Slide. You had the hello.
Oh, this one. Oh, yes.
Yeah, yeah.
This one.
So that Linkerd outgoing there makes an HTTP call to host 2. Is that a persistent connection?
That's a persistent connection. This supports HTTP2 and gRPC. This is also MTLS. They're all encrypted across the wire.
And the hello client has got an HTTP2 connection into.
Yeah. So they can be HTTP1 or HTTP2.
I'm interested
Yeah.
in HTTP.
So these all have persistent connections to their local Linkerd, and then that's got a persistent connection to every Linkerd in the environment.
Right.
And it's
So what happens if host 2 goes away and there's another host? Hello's still got a persistent.
this hello that's making a request still has a persistent connection,
That one
and then
will
this one will
start-
find one that's running the desired app.
Host 3 or host 4.
But I wouldn't recommend running this pattern. Linkerd now subsequently
sure.
does support the Sidecar pattern. It's much better.
Yeah.
So my problem,
In Istio and Envoy, it'll handle failover with.
same, yeah.
Okay.
The main reason I don't like this pattern is actually it's another configuration change in your application, because now instead of knowing what service you've got to talk to, you've got to talk to host IP :4313 or whatever, and then that's actually why their routing is much more complicated. It's because it's not using the original domain to make the request. You have to add some kind of clever rules to figure out where that traffic needs to go.
Cool. Thanks.
So with the Istio stuff, it registers a new node. If you commission new nodes, it will do it.
So Istio currently, as of 1.9, uses a feature in Kubernetes called mutating webhooks. So whenever you create a pod, it actually intercepts your deployment YAML and then adds the Istio containers and initialization to that.
And then a lot of this makes sense, obviously, with the complexity of H2 and gRPC.
Yeah.
Do you push all of your traffic through? Do you push your 1.1 traffic through this as well?
So we push our teams 1.1, but there's a lot of tenants on our clusters that don't use. In fact, it's just us and I think 3 other guys that are currently using the Istio mesh. But I would still use it for all the 1.1 traffic because of the telemetry, the routing rules. It's also got open policy agent built in. You can do your network segmentation with it. Like this.
Presumably the mutual is TLS.
And mutual TLS, yeah. The one thing that we do have an issue with gRPC is if you look here. So with gRPC, if you want to use authorization headers, you have to use a secure connection. It's a constraint that they've added. But that means that in the mesh, you'll see all of our requests that are actually should just go slot machine to bank LDAP go through Istio ingress because we have to do a secure call from the gRPC client. So that's kind of a pain. I hope it'll be fixed soon, but for now it's workable.
And then with that, performance?
Well, you can see here. That's the difference it's taking. So the actual bank LDAP was 21 milliseconds, so we're adding, what's that, 1 point, what? Yeah, whatever it is. 1.4 or something, 1.04. Well, 1 point, I can't do math. That's why Linkerd is too hard. Yeah.
Now, the H2 is weak, right? If you've got an open-ended set of clients,
Well, that's why this is so quick, because your ingress has got a connection already to this pod. So there's no headers or any other connection.
can you lead to any kind of request starvation, like just having too many H2 requests with persistent connections open to clients?
They'll all go on the same way.
We do.
No, but because I'm presuming on the other side of this, we've got clients on the open internet, right? Browser front ends.
Yeah, I mean, we do this whole Chef estate here is frequently checking in and doing HTTP calls for status checks and push jobs checks and stuff, and we don't have any, there's no speed issues. We're running at around 30 requests a second. You can easily push it to the hundreds.
Sitting at an interval of 1 minute.
Okay, then it's
Yeah.
cool.
Any
Cool.
more questions are cool, guys? Anybody got a question? If you don't understand something, go to John.
Awesome.
All right, well, thank you very much, guys. Thanks.